Here, before going to know about functional dependency, we should know about the schema refining. So what is the refinement and the schema refining? Let's see what is schema. First of all, designing of relation or structure of relation is called a schema. So here we designed one employee wages relation schema. So here the employee ID number 3. So employee ID is nothing but a column or attribute. Next number is nothing but a data types, and 3 is the size of the data type. Next like that only ename, employee rate and employee wages has worked also a attributes or columns. Next here the varchar number numbers and 10 to these are the some sizes of the data types, particular data types. So this is the overall designing of the schema. Before going to design a relation, we should create this schema for understanding of the relation, how our relation should be like. Yeah, basically after inserting the data into the relations, some duplication of data will be occurred, that is called as a redundancy here. So after inserting the data, some duplication of data will be occurred, that is called a redundancy. So how to remove the redundancy? Here, to understand about the functional dependency, observe the above table given. So here the redundancy occurs where the employee wages is depends on the column name employee rate. So the duplication occurs here. So here the employee rate means employee wages is depends on the employee rating. Based on the employee rating, the employee wages will be given to the employees. So here the x determines y. So because y is an employee wages and x is the employee rate, means employee rating. So here the one attribute is depends upon the another attribute. So this is called a functional dependency. So here it is also called a integrity constraint, like a primary key, unique key, like that. So here the y depends on the x. So employee wages depends on the employee rate. So this is called a functional dependency. Redundancy occurs due to the integrity constraint, that is functional dependency. Here the x determines y, means y attribute is depends upon the x attribute, that is called the functional dependency. Here in relation R, let's see the example for the redundancy. Here observe the notes carefully. Here t1 dot x equals to t2 dot x, then t1 dot y equals to t2 dot y. So see this in the table, so that you can understand clearly. Here see the table clearly. So here t is nothing but the tuples, the t1 is nothing but the tuple 1 and t2 is nothing but the tuple 2. So here t1 dot x equals to 8 and t2 dot x equals to 8. So both are equal. So t1 dot x and t2 dot x is equal. Then observe in the employee wages table, that is y, tuple 1 t1 dot y and t2 dot y both are equal, so that the redundancy is occurred. Where t1 and t2 are the tuples in R under relation R, and the t1 dot x refers to the value of x attribute in tuple 1, and t2 dot x refers to the value of x attribute in the tuple 2. So the redundancy will be occurred, so both are equal. So here the redundancy will be occurred here. So how to remove the redundancy? There is a solution called decomposition of the tables. So decomposition of tables is nothing but the dividing the tables into multiple tables, so that we can remove the redundancy easily. So here see in this book, such redundancy caused by the functional dependency can be eliminated by the decomposition of the tables, dividing the tables into the multiple tables. So let's see how it will happen. Now I'm going to eliminating this redundancy by using the decomposition of the tables. So here observe the first table, what I given. Here the dependency occurred, the functional dependency is occurred due to the redundancy. So how to remove it? By decomposition of the tables. Here I am doing decomposition. Here see that I divided the table into two. So here employee id is the primary key and ename employee rate hours worked. These are all related to the employee wages one relation. Next, second relation is employee rate employee wages. These are related to the employee wages two relation, so that the redundancy will be reduced. Here we can see how the employee wages to table is designed. So after inserting the data into the table, so observe here it is the first table, so don't get confused here. So here the redundancy is equal to remove that redundancy we divided this table into two, that is the employee wages 1 and employee wages 2 by using of the primary key. So here we divided, so we have to get without a duplication of the data. After dividing, so we can see here the employee wages to table that consists of the attributes like employee rate and employee wages. So without redundancy we got like this, so 8, 10 and 6 and 4. So there is no duplication of the data. By using of the decomposition of the tables, we can reduce the redundancy. So while decomposing the relation, there are two properties that have to be preserved here. So let us see what the properties are. Mainly there are two properties while decomposing the relations. There are two properties that have to be preserved. So the first one is the lossless join property. So there is no data loss when combining again. So what we are dividing the two tables, when we again join the tables into single, so there is no data loss. So that is the specifying here the first property, lossless join property. So let's see the second property called dependency preservation property. So didn't losing dependency here. So after combining the two relations, there is no chance to losing the dependency here. So these are the two main properties which is followed by the decomposition. Let us see the deeply first one by one, lossless join property. Here I mentioned clearly, after decomposing the relation, the original relation must be obtained when the decomposed relations are joined together. So what it is? So after dividing the two tables, so we can check that after dividing, then we have to combine the two tables, then we can get that actual data. If it doesn't get that actual data, so the decomposition you did that wrong. So that is a lossless join property. Next is the dependency preservation property. Here the dependency preservation is nothing but because of the decomposition, the functional dependencies should not be lost on the relations. So after dividing the two tables, there is no loss of the dependency what there in first before dividing the two tables. So these are the two properties of the decomposition or the principles of the decomposition.